Good morning students. In last class already we are discussed about magnetic conduction concept. Okay, how we are representing magnetic conduction. Magnetic conduction will be represented with capital B. So that magnetic conduction is a which type of quantity we are represented, that is we are represented as a vector quantity only. So its directions how we are represented means okay, its direction is away from north pole we are represented, and magnetic induction direction is acting towards the south pole is also we are represented in previous classes. And one more thing students, okay, magnetic induction simple notation by maintaining a distance of some r means like this we are represented. How we are represented means, for example, here b value is equal to mu naught divided by 4 pi into m divided by r square. This type of notations also we are represented. Here m is we are taking as a pole strength and r is we are taken as a distance, like this in previous classes we are discussing. See students, today based on these concepts only few applications we are ready to discussing. Okay, nearly 3 to 4 applications I am not ready to discussing with you. Just we will go through those applications now. Okay students, see students, resultant magnetic conduction due to a magnetic poles. This is the just thing we are mentioned one heading. In that one, what is the first application now we are ready to discussing means, two like magnetic poles each of strength small m are placed at the corners of a equilateral triangle of side A. So once I am repeating, two like magnetic poles each of strength small m are placed at the corners of equilateral triangle of a side A. This is the given condition. So for this thing, how much we are getting the result once we will observe here. See students, here what the thing is given here, one equilateral triangle is given having a side A. So this is I am representing one equilateral triangle like this. Okay students, so here one north pole is present, here another north pole is present. I am imagine. Okay, here at this one corner I am taking one unit north pole. I am represented unit north pole like that only. So this is also becomes as a small a, and this one is also becomes as a small a. In equilateral triangle means here 60 degrees is present, here also 60 degrees, and here also 60 degrees. See students, this is a north pole, this is a unit north pole. In this direction, which one is acting, some b value will be acting. So and also here this is a north pole and this one is also unit north pole. In this direction also b is acting. Let I am taking this one is b1, this one is I am taking as a b2. So here distances is same, and here pole strength magnitudes is also same. Therefore I am taking here b1 value is equal to b2 is equal to I am taken as a b. Okay, so students, here b value how much we are getting, b value is equal to here mu naught divided by 4 pi into m divided by r square we are getting. So students, observe carefully, in between b1 and b2 here 60 degrees means by similar angles here also we will get how much, 60 degrees only. So we want to find out B resultant. B resultant is equal to, this is vector quantity, this one is also vector quantity. Here two vectors just acts as a adjacent sides of a parallelogram. In that condition, we have one formula by parallelogram of vectors, that is nothing but root over here b1 square plus b2 square plus 2b1 b2 cos theta. This is the one standard formula we have. So students, listen here, b resultant here I am representing root over, this one is b square plus b square plus 2b square cos 60 degrees I am representing. Why here theta is equal to how much is present, 60 degrees is present. So here theta value is equal to 60 degrees I am representing for you. So now here the thing is root over, this is 2b square plus 2b square cos 60 degrees value is equal to 1 by 2 students. Since cos 60 degrees value is equal to 1 by 2, so this one will be cancelled. Root over 2b square plus b square is nothing but 3b square we are getting. Therefore here the value is root 3 times of b, so this is b resultant value. So we are identified here b resultant is equal to root 3. B is the result for us. Okay students, all are observed or not? Okay, right. Next one more application also, now we will think it. Okay students, listen students, this is one more thing clearly giving two equal and unlike poles each of strength small m are placed at the corners of an equilateral triangle of side small a. So once I am repeating the question here, two equal and unlike, both are not same, poles each of strength small m are placed at the corners of an equilateral triangle of a side a. This is the given question for us. So for this one, how to find the result, once we will go through that one also. Okay students, listen carefully. Okay students, this is actually a second case for us. For example, this is first I am taking one equilateral triangle of side a like this. Okay students, so ultimately this is how much a is present here. A is present. Let this is one north pole is present, this one is south pole is present students. So here we are taking one unit north pole. Okay, north pole and north pole is present means comma repulsion, or your b value will be acting away from north pole. That I am taking, this one is b1 I am taking. But students clearly observe this is north pole and this one is south pole. So here we are taking one attraction like this. This is b2 we are taking. Here distances is the same, and one more thing is here pole strength values is also same. Here m is constant and a is also constant. Is it clear or not? Therefore we will take b1 value is equal to b2 value is equal to, let that is I am taking as b is equal to, here by concept of magnetic induction, mu naught by 4 pi into m divided by r square we will represent students. See students, this is one vector, this is another vector, this is totally equilateral triangle. So once we will think, here 60 degrees is present, here 60 degrees is present, here also 60 degrees is present. So here what's the thing is present students, here 120 degrees we are getting. So 120 degrees getting means in this direction some resultant will be observed. So this is I am taken as b resultant. See students, here angle between b1 and b2 is I am taken as theta. So now theta value is equal to here 120 degrees I got it. So here by simple parallelogram law of vectors formula, b resultant is equal to root over, I can write as b1 square plus b2 square plus 2b1 b2 cos theta. Is it clear students? So now observe you people only clearly. So b resultant here becomes root over b square plus 2b square cos 120 degrees we will get it. What is the value for cos 120? Cos 120 value is nothing but minus 1 by 2. How much students? Minus 1 by 2. So minus 1 by 2 is substituted here. So this 2 and this 2 will be cancelled. This is plus b square and this one is minus b square. So on cancellation, root b square we are finding. So finally we will get b. So therefore b resultant value is equal to, we are getting as b. So students, this is the third case for you. So how we are getting this case, once observe carefully. If four identical magnetic poles each of strength small m are placed at the four corners of a square, then the resultant magnetic induction at the center of the square is 0. Okay, how we are getting that thing, once we will think it. See students, let I am taking, this is one square I am imagining. So at this square, for this square, how many corners is present? 4 corners is present. So at 4 corners we are placing identical, okay, poles, that is nothing but identical north poles I am placing here. For all these things pole strength is small m only I am imagining. So here n and here n, here n, here n is present. Okay, all sides are equal. Okay, length is present. So this is a length is present, here also a length is present. At center, that person is expecting, students. At center expecting means at this point, okay, we want to find. Let I am choosing this one is origin, some O is present. See students, from the center to this corner, some distance is present, here to here, some distance is present, here to here, some distance is present, here to here, some distance is present. The distance R is remains constant from center of the square. Is it clear, students? So listen here, here to here, one magnetic conduction B will be acting, here to here, magnetic conduction B will be acting. So these two are equal magnitude, acts in opposite direction. Equal magnitude acts in opposite direction means the resultant is becomes 0. Why? Both are in opposite directions, both are cancel each other, then resultant is becomes 0 only. These two will be cancelled out, and the same way and in the similar manner, this direction and this direction, another base will be acting in opposite direction. These two is also cancels each other. So finally at the center of this square, okay, resultant magnetic conduction is becomes 0. So that is the main fundamental thing here. Okay students, next one more application also, now we will revise it. So students, this is the last and final case I am discussing with you. So how the condition given here, once we will revise it. Three identical magnetic poles, each of strength small m, are placed at the three corners of a square of side small a. Then the resultant magnetic conduction at the fourth corner. See students, here three identical pole strengths is placed at three corners of a square, but at fourth corner resultant magnetic conduction, how much is expecting? That is the here question for us. Okay students, now I am starting a solution for that thing. Students, listen carefully. This is one square you must imagine. Okay, so here how many corners is present? Four corners is present, students. So let I am taking this one is side A, this one is side A. Okay, here at three corners pole strength we are representing with n, this is n, and this one is also n. At fourth corner how much is present? For example, here I am taking one unit north pole is I am taking. Between here to here in this direction some B will be acting, and here to here some B will be acting. So listen carefully, this distance and this distance both are same, so this is B means this one is also B only. Here I am clearly mentioning, students, here B value is equal to here mu naught divided by 4 pi into m divided by a square we can able to find. See students, one more thing, this is one diagonal of the square. Diagonal of the square value, how much we people know? This is nothing but root 2a, we people know very well. So one thing, this B and this B are perpendicular to each other. B and B are perpendicular to each other. Is it clear, students? So in this direction, what the thing will happen? Some resultant will be acting. That resultant what I am taking means that is here B resultant, that value is equal to, I am taking as B resultant is equal to, when both are perpendicular, root over B square plus B square. So that is nothing but root 2b square. So that is nothing but root 2b. So B resultant value is equal to root 2b. We are identified, students. So one more thing, this diagonal to this side means here I am taking where b dash value is equal to here mu naught by 4 pi m divided by, here how much distance is present, students? Root 2a is present, root 2a whole square. So finally this is we can able to write as mu naught by 4 pi into m divided by 2a square is the thing. So in this direction b dash is also acting. So by diagram, just imagine b dash and b resultant are in same directions. So total net result we are ready to find. So here b net value is equal to b dash plus b resultant, students. So b dash value is equal to how much, students? That is nothing but here mu naught by 4 pi into m by 2a square, this is root 2b. Is it clear? So then nothing but mu naught by 4 pi m by 2a square plus root 2 into b value is equal to how much, students? Mu naught by 4 pi into m divided by a square. So observe carefully here, mu naught by 4 pi is common and m is common and a square is also common. So finally we are getting 1 by 2 plus root 2 we are getting. So we are getting b net value is equal to like this only. This is the resultant at the corner of the square. Okay students, all are identified this one, all are getting one clarity about this one. Okay, next further we are going for magnetic flux concept. Which concept? Magnetic flux concept. Now we will discuss it. Listen students, magnetic flux is represented with phi. How we can represent magnetic flux? Magnetic flux is represented with phi. Actually students, magnetic flux is a scalar quantity. Which type of quantity we are considered this magnetic flux? Magnetic flux is considered as a scalar quantity. So first of all, how we can go through this magnetic flux concept? So the total number of lines of induction passing normally through a surface is called magnetic flux, we may call it. See students, the total number of magnetic field lines coming out from unit north pole also of magnet is also we are calling as a magnetic flux only. See students, for this magnetic flux one standard formula is present, that is nothing but phi is equal to b bar dot a bar. What is the thing students? B bar dot a bar is the thing. So B bar is nothing but magnetic induction in vector form and A bar is nothing but area vector. What is the thing? Area vector we can call it. So listen here, phi is equal to B bar dot A bar is the fundamental formula. Here dot product we are applying. Dot product we are applying means result is also becomes scalar quantity. So we know very well A dot B is equal to, or A bar dot B bar is equal to, we have one formula AB cos theta from previous vectors chapter. So from that we are writing as phi is equal to BA cos theta. So where theta is the angle between B bar and A bar, also we will represent here, this is a dot product result is a scalar. So here magnetic flux is we are considered as a scalar quantity only. So students, here observe carefully, here one diagram representing, let this is one surface we are taking, that surface area is capital A I am choosing, so that area vector is acting normally in this direction. So this total area will be placed in uniform magnetic field or placed in uniform magnetic inductions, means in this direction B bar is acting, here A bar is acting, in between these two some angle we are showing here students. So phi is equal to general formula is B bar dot A bar, or this is also represented as phi is equal to closed integral of B bar dot dA bar. Okay, how we are represented? Phi is equal to closed integral of B bar dot dA bar, like this also we can represent. So students, now we will discuss about units for magnetic flux. Just remember carefully, in SI system this magnetic flux unit is represented as Weber. SI unit is Weber. In CGS unit is Maxwell. Okay, Weber is a greater value SI unit and CGS is the Maxwell is we are taken as a CGS unit. So what is the general relation between this SI system unit and CGS system unit? Means 1 Weber is equal to 10 power 8 Maxwell. 1 Weber is equal to how much students? 10 power 8 Maxwell is we are preferring. So we will go for dimension formula for this magnetic flux. How we can represent here? Flux is equal to B bar dot A bar, we know that is BA cos theta. So one thing remember all of you students, B, for B we have mt power minus ta power minus 1 in last class already we are explained, and for area L square is the dimensional formula. So by substituting here mt power minus ta power minus 1 into L square, like this we will represent. So dimensional formula is becomes ml square t power minus 2 a power minus 1. These are the things we are ready to discussing. Okay students, in next coming class we will go for axial line of magnet and equatorial line of magnet. On axial lines and equatorial lines, how to find magnetic inductions also we will discuss in next class. Okay students, thank you.